Right. So then we'll start the new chapter. It's going to be a database. This the chapter 8. With respect to the databases, again last week I said you the importance of this. Then we have a second paper complete question, and for the MCQs going around 4, 5, 6 MCQs. Also there can be questions available in the structured paper as well. Then very important for our final paper. Also the section is highly logical, very easy to balance, very easy to follow the chapter. We'll see. Let's start the concepts. So then with respect to databases, the phrase database came with the two words data plus base. Okay. We know what data are. What are data? Raw facts. They are facts or values which are not processed, raw. We have the other word base. What is base? General English. Base is a place, army base, the basement. Right? So we can call this as a place or location. Then what is the whole meaning? Database. A location, a place with raw facts. Then when we have collected lots of raw facts, that means lots of data, we have collected huge volume of data, that location is called as a database. Lots of data combine and make them a bulk. That bulk is called as a database. Then there are businesses, simply most of the businesses, almost every business need to handle large volume of data. What are such? Think of a school. To maintain the school activities, do they need to maintain data? The school administration. They need to record details about the students. Simply, each student has to be given a registration number. Then their name. Then their date of birth. Their address. Their telephone number. Their parents' details. That's some of the details where the school is going to maintain. On the other way around, regarding the school, they need to maintain details about the subjects they offer. What are the subjects offered by the school? Right? Simply a subject name. Then whether they have practicals or not. Then how many periods are there per week. Then also the teacher details, the teacher name, then the teacher NIC, the salaries of the teachers, even the number of days they have attended, even students, the number of days attended. If you consider the school, if there are around 200 teachers, if there are around 3,000 students, how much of data would be handled by the school? 3,000 students. One student will maintain 1, 2, 3, 4, 5, 6, 7, 8, around 10. Then altogether, around 30,000 data are to be maintained along with the students only. Teachers, subjects, and the other resources of the school, the vehicles they have, the staff maintenance, the vehicle maintenance, the painting and everything, the funds, construction, how many things? All should be maintained along with the business called as school. So that they want to maintain all such data in a single location. So then such a location is called as a database. That's the idea. So database is a single location where lots of data are packed together. Then when the school is maintaining or when the business is maintaining such a volume of data, should those data be available in an ordered or structured manner or just keep them? The principal or the administration, do they need to find specific data in some cases? They want to find the attendance of this specific student who is from grade 9 and who is doing science subjects. This is the name. I want to find the attendance of the student. Should that facility be available in the database? Yes. Rather than going through all the 30,000 records, I should be quickly go through that. Now, when handling such a bulk of data, shouldn't they be kept in an ordered, structured manner? Yes. Now, the proper definition of the database is, this is a definition, an ordered collection of data. That's the definition of database. Right? Collection of data, bulk of data, ordered, kept in a ordered, structured manner. Huge volume of data kept. Then, when we want to keep data, the values, the figures in an ordered manner, should we maintain them in the form of paragraphs or tables? In the school, are they maintaining a paragraph about students? This Nimal student has joined into our school on this day with his parents, and his date of birth is this, his telephone number is likewise. Is there an essay about you in the school? No. What is there? Table. Having data in a table is highly ordered. Going through the columns, rows, we can pick up the data easily rather than reading an entire paragraph. Now, databases are maintaining data in the form of tables. What's the idea? Simple idea is database is an ordered collection of data where the data are maintained in the table format or tabular format. Next thing, as I said earlier, schools, so they maintain the data, like I said earlier. Around 20 years ago, simply when we are schooling, were there schools? When we are schooling, were there schools? Yes. Then during that time, did our school have computer-based database, or all these data were maintained on papers or books? Books. Those days computers were not there. For the whole school, only one computer was there. That was kept in an isolated room. Students, that's our experience, right? We were not allowed to reach that computer as well. Being aside, we have to look at the computer. Sir is on the computer and say that, oh, this is a computer. So these are the monitor things. We don't know what they have exam මතකත් නැහැ. එහෙම තමයි කම්පියුටර් එක පෙන්වන්නේ. සපත්තුත් ගල්ලා ඈතින් නම් බලන්න ළඟටවත් යන්න දෙන්නේ නැහැ. කොහොම තමයි මගේ කම්පියුටර් එක්ස්පීරියන්ස් එක ඉස්සරවම ඉස්කෝලේදී. අපි කම්පියුටර් අල්ලාවත් නැහැ. හරි. Then they didn't use computers to maintain this huge volume of data. එහෙනම් ඒ දවස්වල database එක කොහොමද තිබ්බේ? Completely based on books, papers, files. So my argument is databases can be of paper based. Is it possible? Still they maintain data about structured, right? Sometimes principal want to find my file. Hey, oh, Indunil ge file එක. මගේ file එක ගොඩක් වෙලාවට මේ සුඩමයි තියෙන්නේ. හරි. Then they can quickly go through the racks and picking up the file, then go through details and adding new letters into this one and bundling it. But nowadays, the databases are available in computers. We call them as electronic database. Electronic databases are maintained within the computer. Paper-based databases are maintained on papers, files, cabinets. Simply, among these two categories, which database is perfect? Paper-based, the electronic. Electronic. So we have many more advantages when using computer-based database. The best example is our banking experience today. The bank need to maintain details about their clients, transactions, bank accounts as a database. Nowadays, it's in the electronic format. So that through any ATM, I may put my card, and I can see my balance from anywhere in the world, even through online banking. Why? The database is electronic. Were there banks around 50 years ago? Yes. Did they use electronic or paper-based? Banks, is there a paper-based? And all our account details are maintained in books, papers. You can't imagine how the banks were there, right? Then when a transaction, they record it onto a book. And if my account is in Candy branch, can I withdraw money from Gold branch in paper-based? The records are there only in the book written in Candy. I have to come to the Candy branch to do my transaction. But electronic, through the networks, internet, the data spreaded. So then we are going to get much more benefits. So simple idea is that electronic databases are the highly affordable method of handling large volume of data. Right. So then I will go to the introduction here. That's the idea what databases are. Simplest idea. Okay, we'll complete the introduction quickly. Databases. That's unit 8 or chapter 8. That will light. Right. Databases are defined as databases are defined as an ordered databases are defined as an ordered within bracket structured and ordered within bracket structured collection of data. Ordered, structured collection of data. So that large volume of data, are maintained in a single location in a structured manner facilitating to access specific data directly. Next point. Tables are used in databases. To maintain data in a structured manner. Next point. The databases can be available. In the form of paper-based, within bracket manual, in the form of paper-based, within bracket manual, or electronic, within bracket computer-based or electronic, so that the computer-based databases are more powerful than the traditional databases. Next point. Some of the advantages of electronic databases, some of the advantages of electronic databases are, right. Then what are the advantages of electronic databases with respect to the paper-based data? What about the room space required to manage data in electronic? Only a space to keep the computer, whereas paper-based now, we have to arrange books, files, huge cabinets here. Now, the main benefit is need smaller room space than the paper-based. Our benefit, we'll write them later. We'll just have the discussion quickly. Another benefit of electronic databases, whenever the data available in the electronic format, what about distributing those data? Exchanging those data is highly supportive by through the networks, internet, people can access data from anywhere. Online banking, your O-level, A-level results, those people will, examination department will compile your data, results and put them into a single database server. So from anywhere in the country, you are going to access it. Now, sharing the data is still highly profitable as well as highly efficient. Further, what about the security added into our electronic databases compared to the paper-based? So paper-based now, all your data are there in cabinets. Here, these are the papers. Now the data in the computer. Then how can you protect the data in the paper-based environment? All the files, all the books are put into a cupboard and locking it and take the key. Whoever owns the key can only open it. Is it possible with electronic as well? We don't have the physical key. Instead, we have the password locks. All the data put into the single database and we put a lock. That's a password lock. Whoever knows the password can only open it. Now, that's going to be almost the same. Other benefit here in the electronic is whoever has the key in paper-based can enter into the room and do whatever on data. So that in our school time, if I have a bad record in my file, I am trying to remove that. If I get the entry to the room, can't I open the file and take that paper out? By whoever opens it can do anything onto the data. In this case, electronic, it is possible to set access permission. You all know that when you are doing online banking through your computer, you are able to access your transaction details. Can you erase your previous transaction? You withdraw 5,000 rupees, you want to erase it. Then your balance will be restored back into that plus 5,000. But you can access this. Then you are being given, the administrators can set up permissions who can update data, who can read data separately in electronic form. But paper-based now, no such permissions can be given. Whoever has the access can do anything. So we call this as access permission or access rights. So that is giving more security on your data along with the access permission. Now, what benefits in electronic? We can share them. Then what about the backup of our data? What is backing up? Copying our data. Keep a copy of this original data in some other place for the protection. If there's a disaster, if there's a damage to the data, we have the data in the copies. Is it possible to be done in paper-based environment? All my data are in files, papers. How can I copy them into another safe location? Photocopy all the data and keep them in another cupboard. That's possible. But is that convenient? All the books, all the files have to be photocopied. And also I need to have similar room space to keep the backups as well. But in this case, what do? You copy all the data in your electronic database into another pen drive, into another cloud storage, and let them be there. If there's a virus infection, if there's a natural disaster and damage your original database, we have them available in the cloud. We can get them back. Efficient backup procedures are available in our electronic databases, which is not available in paper-based. Right? Then another point is the data are portable. That can be equalized into the earlier point. Portable means data can be carrying here and there. One thing is through networks. By copying them to pen drives, we can carry here and there. Likewise. Right? Then in that manner, electronic databases are giving you much more benefits than the paper-based environment. So we'll just go through some of them, may be important for your small MCQs. Right? We like some of them are, we said that, right? Some of the advantages are, we'll go to points. First point, need smaller room space. First benefit, need smaller room space. Need smaller room space. Next benefit, can share data easily. Can share data easily. Within brackets, right? Within brackets, data are portable. Can share data easily. Data are portable. Next benefit, efficient backup. Efficient backup practices. Efficient backup practices. With a hyphen, right? Using cloud storage. Using cloud storage. Or external storages. Next point, more security features. More security features. Such as, more security features such as access permissions. Access permissions. Covering, read, access permissions covering, read, write, comma, execute permissions. Covering, read, write, execute permissions. Right. Then one more thing. Say that that's also a good point. Whenever we are going to go for the paper-based environment, right, manual, I am going to fill data about teachers in the school. This is a table to record data about teachers. Paper-based, right? This paper. Right. Then I am the one who are writing those data. Right. Papers now we have to write them manually. Then this is the teacher name. This is the telephone number. This is the city where they live. Then there are some data already. We just say that teacher name is Nimal, telephone number is 077, city is Kent. Then when I am writing the data for the second teacher, I'm the one who is updating the data. I'm on a discussion with some other person. Mistakenly, I am typing the name as Kamal. No issue. Under the column telephone number, I am typing the city Colombo. Mistakes. And then somehow I may write some other value here as well. Mistakenly, I did so. When I am doing such a mistake, will that be informed by the system to the data entry operator, to the person? Will the paper shout and say that, hey, how can you write Colombo under the telephone number? But if this is going to be the computer, when I am typing a text-like data under the telephone number, will that give me an error message? You can't have a telephone number with this pattern. Isn't that another convenience for the user in electronic format? So then what are they technically called? We can call them as constraints or rules. Constraints or else rules. It is possible to set rules onto the electronic database, focusing to reduce the data errors where the humans are making. You understand that? Which is not there in paper. That's another benefit technically. We like the other one. Possible to other benefit. Next point. possible to define rules within the side constraints. We need this term. Possible to define rules, constraints. Possible to define rules, constraints to maintain data with lesser amount of data entry errors. With lesser amount of data entry errors. All right. These are some of the benefits. Then there are many more. So we'll stop from that point since they are not that technical. Just to learn that this is the nature of the electronic database. Right. Then we conclude that electronic database is a better version than the paper-based. When it comes to the electronic database, right, all the data related to the situation are maintained in a single file. This is called as a database file. Right. Forget about database, come to this way. Now I am going to watch a film. So one of my friends says that there's a new film came, so didn't you watch it? I said, no, I didn't. Then I'm telling, can you please give me that film? He said, okay, I'll copy that in the pen drive and give you may watch it. Right. Then the film is available in my pen drive. Right. Then this film has the necessary data. Film comes as a file, right? You understand that? Copy කරාට පස්සේ file එකක් දෙන්න දෙන්නේ pen එකේ. Isn't that file contain the necessary data of the film? What are the data related to the film? Just like those text data, numeric data, or pixels, sound, they are the data. Pixels are there, right? The frames are there, and sound data are there. And that's the data related to the video file. Sound as well as pixels are there. Now I am coming to my computer. Plug that pen drive into the computer. Unfortunately, in my computer, there is no any media player software installed. Media player එකක් නැහැ මගේ computer. Windows media player එකක් නැහැ. VLC player එකක් නැහැ. KM player එකක් නැහැ. වෙන මොකුත් කචල් players එකක්වත් නැහැ. දැන් මම pen එක ගහ ගන්නවා computer එකට. I plug the pen drive. Then I can see the file here. When I double click, can I open that? It won't open unless having the applicable software. Likewise, when you go for the electronic database, all your data in the form of tables, columns, and everything are available in the database file. This is a database file. In order to open this database file in my computer, shouldn't I have the corresponding software matching with the database operations? Database file එකේ ඔක්කොම ටික තියෙනවා. කොහෙන් හරි copy කරලා ගත්ත database file එකක්. I want to open that in my computer. For that to happen, I won't have a particular software. Is media player supporting me to open a database file? Media player එකෙන් database එකක් open කරන්න පුළුවන්. එනක ඉතින් අටපට්ටමට කියන්න දෙනවා නේ. හරියක් කරා කියලා. Or else, is it possible to open database using Paint-like software? Paint is supporting to draw things. How can it show you tables and things like that? Not only showing, we have to add data, protect data, lots of things are there. Now, for that to happen, we need to have a software to support database activities. What are such softwares where they support the database activities? People who did ICT for O levels? MS මොකද්ද? Access. The one we have to use in our A-level syllabus, MySQL. SQL Server. Then Oracle is also there. Nowadays, the brand name has been changed. Oracle. Even the old one, DBase 3+. There are many other versions. Out of them, we are going to use MySQL. These are some brand names of the softwares supporting me to work with databases. Now, all together, these database related softwares are called as what? DBMS. So then DBMS means a type of software where they facilitate the database activity. DBMS stands for what? Database Management System. That is what DBMS is. Next subtopic is DBMS, Database Management System. We'll quickly take the note. DBMS, Database Management System. Right. We'll write under that one. DBMS. Is the type of software having the facilities to work with electronic databases. Examples list: MS Access, MySQL, SQL Server, Oracle, DBS 3+, තව වෙන ගොඩක් තියෙනවා. Open Office වල එහෙම තියෙනවා. MS Access, MySQL, SQL Server, Oracle, DBS 3+. Right. Now, the incident is when a user, you and me, are going to work with an electronic database. There we have data tables, data and everything. Can I directly reach the electronic database, or should I go through a DBMS to access this data? Without the software, can you update those data or read those data? No. Then this is a flow. User has to go through a DBMS in order to reach data electronically. Right? It is a must. Here we have the user has to go through the DBMS, that is a software, to access the real database which is in the computer. පොඩි concepts, right? Kang ඔලුවට දාගෙන යන්න ටක් ගාලා. මේ බර නැති හන්ද මම ඉක්මනට කරන්න යන්නේ, right? Right. Then that's the requirement of the DBMS. Now we go to the next subtopic called as database models. So these regarding the electronic databases, computer-based databases, we are going to categorize them into different models or types. It comes due to the reasons like this. You can remember in our first 2 chapters, we covered the evolution of computers, the development of computers. First generation computers, then second generation, third generation, fourth generation, 5G likewise. So gradually the computer technologies were developed. It's a computer technology. Then during the 1G, 2G time period, somewhere around 1950s, 1960s, computers were there, very primitive level. Those days, the people had the requirement of handling databases in the computer. You understand that? It was compressive bar. They were with the electronic databases. But are they powerful like the databases we use today? Today we are using highly sophisticated, secured, encrypted, everything is there. Then when the computer technologies are developed to the next level, whatever the database concepts which were in 2G had been improved little bit. Then that had been improved little bit. Likewise, parallel to the development of the computer, database concepts were also developed step by step. Then based on that development, we are going to categorize our databases into few models. One is called as flat file database model. That's the initial level. Then the hierarchical database model. Hierarchical database model. Then after that, network database model. Then relational database model. Next one, object relational database model. So then these are the available database models that we need to cover in our concepts. And in modern days, these days, which model will be using here? Flat file the, object relational the, hierarchical the, relational the network. Guess nikan danne nikan kiyan guess කරලා යන්න chance. Relational database. Not this one. Right? Just like the development of the computer. So we are in 4G, not in 5G. Still we are in between 5 and 4. Same like here, relational is the modern version, quite going into the stepping into the object relational. That's why I said that this is going parallel to the development of the computer as well. We'll see what they are. Right? We like database models, right? Database models. Under that we like the electronic database concepts. The electronic database concepts have been evolved, within like I said, developed parallel to the development of the computer. Parallel to the development of the computer as given below. Takala dakan පුළුවන් නේද? Flat file database model, hierarchical, network, relational, object relational. Right. Then I will go to the first one, flat file database model. flat file database model. Now, this says that the very primitive database model which was introduced at the very beginning. The concept behind the flat file database is very simple concept, very primitive. Those days the computers are not that developed, no huge technologies, but they may try to maintain the computers electronically. Then under the flat file database model, the main concept is they are going to maintain only one single data table. Only one single data table. That's the objective. Only one data table has to be maintained. If it is a school, if it is a bank, whatever the organization, only one table will be there. I'll just go to an example. That's very simple. Then no need to go for much more technical details. We saw everything in one single table. Right. Then with respect to a school, now I am going to go for a school database prepared in the flat file mode. Right. Then first of all, I am going to go for the student details. I may say that student ID, the registration number, and the student name. In the school, they need to maintain student details and the date of birth. Sometimes the grade where they study. For the moment, we'll stop from there. Not only that, school needs to store details about the subjects they offer. Students are following subjects. And I may go for subject ID, then the subject name, then whether the specific subject has practicals or not. Whether it has practicals or not. And then further, the number of periods. Then we need to school need to maintain details about the teachers as well. Teacher ID, then the teacher name, the salary, even the telephone number. This is the flat file database related to the school. Right. Now we'll add some data. Student ID. For student, I may say 001. We'll go to the name as Nimal. Date of birth, we'll put it as 2010, 1st of 1st, in grade 11 or wherever. Subject ID, I may say that MT10. Subject name, maths. That means this Nimal student is in grade 11. He is doing MT11 as the grade 11 mathematics. I'll say that MT11. And that has no practicals. There are 8 periods per week. And this is being taught by a teacher called as T001. We'll call this as Manel. Salary, we'll put it as 59,000. Telephone number, note 771111. Then we'll go to another student detail. S002 student, going to be Kamal. Born on same year, we'll say that 2010, 2 of 2, still in grade 11. Shouldn't this student do the same subject? If they are from the same grade, in O levels, we have to do all the 9 subjects. And he's doing MT11. The subject name is maths. Practicals, no. 8 periods. Who is teaching grade 11 maths? T001. Manel. Salary. Telephone number. If the next student from grade 11 is considered, shouldn't I repeat that? If there are 200 students in grade 11, I have to add 200 details. The earlier data is going to be still repeated for 200 times. Another student S003 is called as Bimal. He may be a 2011, 3 of 3. He's from grade 10 then. We'll say that he's doing SC10. That is science subject. Practicals years. say that there are 9 periods conducted by T002, we'll say this as Onalani or whoever. Then salary may be 62,000. Telephone number note 7722. Alright. Then same student S003 from grade 10 can't do another subject. Full one. S003 Bimal 2011 3 of 3 from grade 10 doing IT 10. That is ICT as a subject. Practicals years. There are 7 periods. Then are taught by some other teacher. Say that some other teacher, Janaki or whoever. Then salary may be somewhere like 58,000. Note 77333. So in this manner, we can keep maintaining data. What is the main weakness here? Data are repeatedly maintained. Is that repetition required or unnecessary? Unnecessary name MT11, all these data are going to be repeated for 40 times, 200 times. Not necessary. If you write them once, that's more than enough. Under the flat file mode, we have to maintain all the data in one single table. That leads to unnecessary data duplication. That's a big issue. Right? So then technically, when you go for this unnecessary data duplication, it has a nice word which is called as data redundancy. Then main issue in fact file is data redundancy. Learn this term. This may be there in your MCQs. Redundancy of data means unnecessary data duplication, right? This is important. Getting duplication is fine, but unnecessarily they are being duplicated, a big issue. Due to the data redundancy, what are the other issues we people will experience? Data are repeatedly maintained. What are the problems in it? When you save them in the computer, what about the storage space required? Isn't that wasting the space? I want to use the space for this. Even same, if I'm to have them repeated for 200 times, I'm going to waste my space. Why? Same data are repeatedly handled. Right? So then one weakness is waste of your space or storage space. Another issue, now these data are added into the table from the keyboard by typing it by people. People have to enter those data. When entering, if someone make an error, say that the telephone number of this teacher, MT001, this teacher details is repeating for many more times. Then in one place, he is typing this telephone number as note 77888 as a mistake. Other places, he is typing as 111. Now, what about the whole database? We ask, what is the telephone number of T001? Then one says that note 788, others says that no, it's note 7111. Then which one to believe? A problem. Therefore, when you are repeating the data, there is an issue of accuracy of the data. If a mistake is there, that leads to a big mess in our data, which is the correct data. On the other way around, when you are going to update data, say that the salary of the teacher, 59,000, has been improved into 60,000. How many times should I update it now? One place or 200 places? Every place we have to update it manually. Go through the table, update it. If we miss to update one place, leading to erroneous data. Updating of data is also going to be a big issue. That file is completely a mess. But according to the primitive level, somewhere around 1950s, 60s, this was a successful event. Why? They maintain them in the computer, can go through the records here and there. On a first model of database called as flat file, which is not an efficient model at all. But learn what it is and learn the weaknesses in it. We like the first one, flat file database. I just spend time on this to show you the issues there, right? Okay, we like flat file databases is the most primitive is the most primitive is the most primitive database model is the most primitive database model full stop. The main concept of the flat file database, the main concept of the flat file database is maintaining only a single data table, for the entire database, for the entire database. Example, consider a flat file database, for a school, to maintain details about students subjects, teachers, right? Then leave space for this whole table to be taken, right? I have added that photos into the group. Copy that later, not now. Otherwise, it's wasting our time. Then when you're drawing that, you have to be careful, right? Why? Big table, better to use some other separate sheet and fold it or whatever. That's your technique. Somehow maintain this. That is very important to identify how they are going to be. Right. Then we light after that, leave a considerable space for the table to be copied. Then we light. Right. After that, we light. The flat file databases are having the main weakness as the unnecessary data duplication. Which is called as data redundancy. Example, the subject MT11, is followed by all grade 11 students which is repeating. Next point after the example, next point. As a result of data redundancy, there are many issues created, such as now go to point. First point, waste of storage space. Waste of storage space. Next point. When there is a mistake, within brackets write data entry error. When there is a mistake, within brackets write data entry error. When there is a mistake, data entry error takes place for repetitive data, comma, there are conflicts of the values, leading to erroneous data. Example, different telephone numbers of the same teacher. Right. The other problem, the next point, different telephone numbers of the same teacher. Next one. When updating a value, comma, the update has to be applied into all the repetitive records, comma, places leading to more time taken, and many more mistakes. So they are the main issues in our flat file database model. That's fine. Then that's the initial level flat file. Then after that, the other model came into the world, which is called as hierarchical databases. Second one, hierarchical database model. What is hierarchy means? English? Hierarchical level. Company, organization has hierarchy of employees. The manager, the whatever the next level likewise. Different hierarchies are there. In our school, still the principal is the top level. Then whatever the sectional heads are there, or the vice principals, sectional heads, class teachers, likewise hierarchies there. Then hierarchy means the tree order. We have the top level, and then the next level Even along with the next level, we have some other levels. This is what the hierarchical concept to be told. Simply, it's giving you the tree-like arrangement. That's a hierarchy. When the hierarchy is set up like this, in a hierarchical order, is it possible to have connections in parallel level? Tree level එකේ මෙහෙම connections තියාගන්න පුළුවන්ද? බෑනේ. Then that it won't be a hierarchy then, right? And is it possible to have a connection from this level to the other level in a crossway? Still not possible. Hierarchy කියන්නේ ඕක නෙවෙයි. Top to bottom. Simply we say that hierarchical model, tree model has only parent to child connection. So this is the child, these are the parents. Parent has child, that's all. Top to bottom connectivities have to be there. Now, whenever we have the flat file, what is the issue we had? Flat file concept is maintain one table. Having one table gives you redundancy. And to avoid redundancy, what have you to do? Keep one table or break this data set into multiple tables. එක table එකක් තිබ්බොත් නෙමෙයි repeat වෙවි යන්න ඕන. Then I will propose to break this data set into multiple tables. See the incident like now. Regarding the student details, now I am going to maintain a single table for student. For subjects, I am going to maintain only a subject single table. Then I am going to have 3 separate tables. Then බලන්නකො මේ. So this table is called as student. Then this table is called as subject. This table is called as teacher. This is a teacher table. Their separate tables have no single line. Then මොකද වෙන්නේ බලන්න. Under the student table, I am going to record the student details. S001 Nimal, date of birth is this. Is it important to repeat the same student again and again? S003 is there, Bimal, this thing. These are only table. In the same table, I am repeating the same detail. Is it worth or useless? Useless. Isalla, in the previous flat file mode, I repeat them. Is that meaningless or it that having a meaning? It has a meaning. When we have the same big record, Bimal is there telling that he is doing this subject. And Bimal is doing the other subject. So we have to repeat them. Now they are individual tables. When you consider the student table, at that moment, I don't want to think of the other tables. So useless to repeat the same data, then won't it avoid the data redundancy? And now I don't want to repeat the same student details. I'm removing this. Now S1, S2, S3, independent students are maintained. Even the subjects, MT11, MT11. Should I repeat it? Useless. Then instead I may go for some other record. This is MT10, say that grade 10 maths. Then no practicals. Then again teacher details need not to repeat it. Why? They are independent tables unlike the earlier situation. So then the main benefit there is this is removing the unnecessary data duplication, the redundancy. And that's the only option how we have. Now I'm asking, there's another student, I may add S004, Kamal, Bimal, Nimal, Bimal, okay. Born on 2011, 3 of 4, there are subjects, there are teachers. Now I'm asking, who is teaching SC10? Who is the teacher to teach SC10? Under the hierarchical model, no flat file. Details are separately available. And there are 3 teachers available in the table, teacher table. Now I'm asking, who is the science teacher to teach SC10 subject? In order to find the corresponding teacher, shouldn't I have a matching detail from this table to the other table? In the earlier case, did I have that problem? No. Now this is directly went along with the record in the row. Then we can find who it is. But now there are individual tables. I can't find who it is. If so, the subject table, the teacher table should be connected. We call them as related. Relationship has to be there. Then when relating those tables to produce meaningful information, we have to follow the tree structure. That's why we call them as hierarchy. We split the single table in flat file into multiple tables. That's good. Avoiding redundancy. But having them along is not sensible. So we have to connect them. When connecting, we have to form the connectivity among the tables in a tree model. As an example, I may say the top level, okay, this is a root level. This is just a sketch for you to understand, not the proper order. Then I will say a table like student. Then a table like subject. Then simply say that subject details are available here. And under the subjects, I may go for another level called as subjects are taught by teachers. Then teacher details are available here. Then some more students are doing sports. Sports details are there. Also different clubs are there. ICT club, Interact club, those details are also there here. They are being followed by students. Likewise, I may arrange my hierarchy. In this case, is it required to have the connection between student and subject? Students are following subjects. Then don't I need to find what are the subjects followed by the student? I need. If I connect them in this manner, I have to have a connection in the horizontal level. Is it applicable to be in hierarchical model? Now, when we are strict into the tree model, there are some confusions when arranging the connectivities. Why? There are places where I want to go for cross connections, subjects and the club. Luckily, it's not, right? But teachers are responsible of the clubs, advisors or whatever. Then we need to have the connectivity. Can't establish to maintain the tree. So then there are some connectivities to be arranged other than the tree model, so it is not practical. Otherwise, this is better than the earlier level. Flat file eකට but we need to arrange the connectivity from the tree model. Tree is limiting the connectivities we want to have. If make up fail, then we are going to the next level. We like the next one, hierarchical database model. Under that we like hierarchical database model. To avoid data redundancy, in flat file database model, the tables are separately considered. And maintained under the hierarchical database model. Example, the school database maintains separate tables for student, subject and teachers. Next point, after the example. Then after the example, leave space for this whole thing to be taken, right? Now, 3 separate tables. Then this is a single table, another table, the table. වැඳගන්න ඉතින් ගෙදර කියලා වැඩක් තියෙන්නත් එපා නේද? අයියා අම්මලා ගෙදර ගිහම කියන්නේ මොකද්ද? අම්මලා පාඩම් කරන්නේ නැද්ද ඔයි? ඉතින් ඔයගේ ටේබල් එකෙන් දැන් ඉන්නේ ඉතින්. මේ අඳිනවා, මෙයා පාට කරනවා, කොළ නමන, ඒ වගේ කර ඉන්නේ. එතකොට හරි. ඒ ලෙවල් ළමයි නේ. මොන්ටිසෝරි ළමයි නෙවෙයි. එහෙමවත් කරනවා ලොකු දෙයක් අර මගුල ස්ක්‍රෝල් කර කර ඉන්නවට වැඩිය. හරියනේ. Then we write to produce leave space and we write to produce meaningful information. To produce meaningful information, it is a must. To produce meaningful information, it is a must to arrange the connectivities among, to arrange the connectivities within the site relationships, to arrange the connectivities within the correct relationships among the above tables, among the above tables. Next point. But the relationships are limited, into a hierarchical, within the site tree model, into a hierarchical within the site tree model to maintain top to bottom, comma, parent to child. These words are important. Top to bottom, comma, parent to child connectivities. Top to bottom, parent to child connectivities. The main structures ටිකක් දාගන්න. These are still in the group. Photos ටික මම දැම්මා. Tree arrangement එක කොහොමයි වෙන්න ඕන. හරි. Then after that we'll write the tree model of the connectivities. After leaving space, the tree model of the connectivities are restricting the association, among the tables, Therefore, the hierarchical database model is not a perfect solution. Within brackets දාගන්න දැන් මේ ටික අපි දාගන්න ඕනේ. Then student subject can't be connected නේ. දෙදෙනා එකම level එකේනේ. Within brackets right? Student comma subject cannot be connected. Within brackets right? Student comma subject cannot be connected. Copy this right? නැත්නම් තේරුම් ගන්න. Student comma subject cannot be connected. මේ arrangement එකේ. හරි. එහෙනම් දැන් case එක මොකද්ද වෙන්නේ? Hierarchical එක හොඳයි, avoiding redundancy, but the issue is can't connect them, can't maintain the tree order. And then we are going into the next level. What is that called as? Network database model. That is came after the hierarchical model. So hierarchy has a profit. Why separate tables are there? That is reducing redundancy. Then tree is the issue. And network says that you are allowed to connect tables even going beyond the tree model. Without restricting to the tree model, you may connect any table as you wish. And tree කතාවක් නැහැ. Now, here I have the student table. Here I have the teacher table. Here I have the subject table. According to your wish, you can have the connectivity. Then no issue. Those connectivities are maintained manually along with each and every record. You don't get it. Simply says that now here student, this student S003 from the student table is following MT10 subject. He is from grade 10. Now, whenever the data are added to the BIMAL into the student table, the one who operates the database should connect this record with the matching records of the other table. After entering data, simply say that you may click here and drag and drop here. Then the connectivity is arranged. Click here and drag and drop. Click here and drag and drop. So manually we have to connect the matching records from whatever the tables. Then who should connect the matching records? Automatically your person should do it. Person should do it. So මේක drag and drop කරද්දී වැරදිලා උඩයකට වඩනොත් එහෙනම් මොකද වෙන්නේ? මූ grade 10 ඉන්නේ grade 11 මැසුත් කරනවා. හරිනේ. Sometimes when he connect them, he may miss one of the connectivities to be added. Hey, these are human works, manual connectivities. So when humans are there, what is the problem? Errors, issues. ඒකනේ අපි sorry කියලා වචනයක් use කරගෙන යන්නේ. Sorry. ඒක shape කියලා හිතන්නේ. මෙතෙන්දිත් එහෙමයි, the connectivities among the tables are not limited. You can connect whatever the table as you prefer, but manually the connectivity has to be arranged. So then that leads to another issue. There are mistakes available. So then network is also not a perfect model, but good, better than the previous methods, having some issues as well. Okay, Kata. We like the next one, network database model. We like network database model. Is solving the problem of maintaining the tree order to connect the tables, tree order to connect tables, so that any of the data table can be connected to any other data table within the database. Right. Next point. But the connectivities among the data within brackets, right, records, comma, rows of data. Connectivities among the data, records, rows of data. Rows of data have to be added manually, among the tables, which may lead to mistakes, so that network database model, so that the network database model is not successful. Network database model is not successful. Then before going to the next model, I want to introduce you some keywords, very simple keywords. Then that would be better for me, right? Now in our database concepts, in our databases, I said you a word called as record. Record. So technically, record in a database refers to a complete row of data. Record means complete row of data. Data, full row in a table is called as record. Then how many records are there in the student table? Student table, how many records are there? 1, 2, 3, 4, 5. Record means complete row of data. And is this counted as a record? This is not having data. Data making data. And how many records are there? 1, 2, 3, 4 records are there. But it has to be complete row, right? Full row, not half. That is called as a record. Record is also called as tuple. Database use karna. Tuple is the record, full row of data. The other keyword I want to introduce is field. In some cases, we call this as field name as well. The correct word is field name, but we call this as shortly field. What is field? Field is a column heading available in a table. Then student ID is a field. Student name is a field. DOB is a field. In the subject table, sub ID, sub name, they are fields. They are simple keywords. So before going to the next model, shall we take those keywords as well? With the start, we like record. Keywords record within brackets write tuple. These are keywords. Better to take them. Record within brackets write tuple. They will like tuple. A complete row of data. A complete row of data. Complete row of data in a data table. Complete row of data in a data table is called as a tuple. Is called as a tuple. Right? A full row එකක් වෙන්න ඕන. The other keyword is field or field name. Field or field name. Field name with a hyphen, right? Columns of data. Columns of data. Or columns of data. Or the column headings. Or the column headings in a data table. Or column headings in a data table are called as fields. Are called as fields. එහෙනම් ආයෙත් මම කිව්වොත් whenever we go for the network database model, the one I told little while ago, network database model, is that connecting tables with the help of records or fields. Records වලින් connect කරන්න. මේකට plug කරනවා manually. So then connectivity will lead to a problem since it is done manually. Now we are leading to the next level, that is called as relational database model. That's a fourth level. Relational model is the one that is used in our current world. And is this having issues or highly successful? Perfect, successful. Right? Then still this is maintaining multiple tables like above. And among the tables, the connectivities are added using the fields. That means columns are used to connect the table. I'll go to a certain example. I'm going to connect the subject table with teacher. As I said earlier, subjects are taught by teachers. Then at this moment, they were not yet connected. Now, I want to find the relevant teachers who are teaching these subjects. Now, what I am doing is, I am introducing one another field or column into the table subject, called as TID. Then telling that MT11 is conducted by the teacher T002. MT10 still T002. Then SC10 T001. ID10 T003. So I introduce the column field into the table subject. Now are these two tables connected or not? Now I am asking the contact number of SC10 teacher. Who is conducting SC10? T001. With that, I am going to the other table and find Manel is a contact number. Are these connectivities are added manually, or when I am entering the data to the subject table, the specific connectivity will be arranged? Subject table data දාද්දිම මේ connectivity එක හැදෙනව නේද? ආයි හදලා ඉවරලා මේකෙන් අරකට connect කරන්න එහෙම මොකුත් ඕනේ නැහැ. එහෙනම් will there be mistakes to the connectivities? No, your record is automatically connected with the other table. And this is why we call this as a successful method to arrange the connectivities. Since we maintain separate tables, no redundancy as well. So no limitation to a tree structure. With this arrangement, it is possible to connect them. So don't worry, our whole entire chapter is about this relational database model. We have a lot to learn. Until then, the brief introduction is the benefit compared to the others. That's the idea. So a big discussion is there. But we like the next one, relational database model. There we like relational database model. The current database model, practically used in the modern world. Practically used in the modern world. It is highly successful. It is highly successful when compared to the previous database models. When compared to the previous database model. The separate data tables, next point, the separate data tables are connected to one another, using fields, within the columns named as primary keys, and foreign keys. Primary keys and foreign keys. Example, the table subject and the table teacher, are connected to one another are connected to one another using the common column, teacher ID. The common column teacher ID. එහෙම කියලා මේ table එක දාගෙන ඉඳී තියාගන්න. So this is called as a foreign key. We'll learn them. මොකද්ද foreign key? We'll learn them clearly. For the moment, foreign key, primary key, and this is the way how they are related to one another. This is perfect when compared to the previous models. Then we go to the other model. What is that? Object relational database model. The next model, object relational database model. What is that? Is relational database model successful? Is it successful? Yes. ප්‍රශ්නයක් නැහැ නේ. චෝක් හොඳටම හොඳයි. ඒ තියද්දී ඇයි තව එකකට දඟලන්නේ? That's the nature of human, right? අපිට කොච්චර හොඳ එකක් හිටියත් මදිනේ තව ඒවා හොයනවනේ. ඔක තමයි මෙතනත් උනේ. ඒක හොඳයි එක පැත්තකින් අනිත් පැත්තෙන් නරකයි. පරිස්සමෙන් කරගන්න. Object relation is also like that. Relational database model is perfect, going well, fine. While having that, we are inventing some more successful methods. It is something like this. Normally, I'll go to a particular example. Now, you people check your O-level results. කොහොමද බැලුවේ? ඉතින් ඉඳලානේ බලන්න නැත්තේ ගොඩක් වෙලාවට. You have your phone, you have your computer. So this is a computer. This is a phone. Then you connect through the internet where to the Department of Examinations website. So then this website had the database of your results. Is this database having details about you only or all the people who have sat for the O-levels in that year? ඔක්කොගේ details එක තියෙනවා. Then being here, I'm going to access that. කොහොමද අපි කරන්නේ? When I'm going to access the database, think of you people. How did you access this database? Now this database is having the results database. Then results database access කරේ කොහොමද? Did you access that database using Microsoft Access, MySQL, Oracle එහෙම කරලාද මේකෙන් data ගත්තේ? නැත්නම් did you access through a web page? Web page එකනේ access කරේ. Then is web page database? Web page කියන්නේ database එකක්ද? නෑ. That's something else. We'll learn that web development in the next chapter. Database කියන්නේ separate object එකක්. Web page is some other object. Other example. You people are doing online banking. Then to do the banking, still we have to reach the banking server where all the data are available in the database. But in your phone, will you use the database or are you using the banking app? Banking application, what is that? Is that the database or is that a software? App can a software? Point is, general humans, general public, are they having the technical knowledge to reach databases and get those data from the tables and columns and everything? General public yeah, IT කරන ඕගොල්ලන්ටත් බෑනේ. තාම ඉගෙන ගන්නත් නැහැ. Database එකේ මේ table වලින් data අරගෙන commands දීලා කොහොමද ඒව ගන්නෙ? එහෙම අපිට බෑනේ. එහෙනම් to make the database user friendly, this database has to be connected to a web page, has to be connected to a software. Then people are accessing that web page or software. So through the software, database is providing the necessary data and we are going to get it. Right? Then handling the software, clicking buttons, clicking drop down menus, isn't that convenient for us? Take a shake. Users are there in a user friendly environment. Really data available in the database. And practically, whenever we maintain databases, think of the computer point of view, developer's point of view. Should they merge this database always with web pages, softwares, applications? නැත්තම් database එක අමුයෙන්ම ඉන්ටර්නෙට් එකට දාලා දිනවා වෙන්න data තියෙනවා ගණන් කියලා දාන්න පුළුවන්ද? බෑනේ. ඒක merge කරන්න ඕන applications වලට, web pages වලට. Then only people are going to reach those data nicely. එහෙනම් in the ICT world, the databases are not maintained alone. They must be connected to the softwares or programs. Okay, නෙමෙයි. Then only we are going to make a practical application. අනිත් angle එක දැන් ඔය programming කරන්න කලින් මම ඔය කරන්නේ. Pick me app එක බලන්නකෝ. Then using the Pick me app, can't you find your previous travels? කලින් ගියපුවා ගන්න බැයිද? කොහෙද ඒවා රෙකෝඩ් වෙලා තියෙන්නේ? software එකේ database එකේ තියෙනවා. database එක තියෙනවා. දැන් ඒගොල්ලෝ database එකක් තියෙනවා. But are you typing commands to access the data from the database? app එක නේ use කරන්නේ. All the time database has to be connected with the corresponding application. So that whenever we go for the recent database model, object relational database, this is using the ordinary relational database concepts, the one I said earlier. And that is applying some complex programming concepts in order to make the softwares attached with databases. Some better facilities are combined into our database. ටික ටික තේරෙනවා. හොඳටම තේරෙන්නේ නැති වෙයි. හරි. ඒතර object relational කියලා කියන්නේ relational එකේම improved version එකක්. The improvement supports to develop, to merge databases with the programming languages, programming concepts. Now, it's highly supportive to make applications in the real world which are using the database applications. Database එකයි software එකයි හොඳට merge කරන්න පුළුවන් concept එකක් තමයි object relational කියලා කියන්නේ. හරි. Theoretically, there's another term comes here. It is using object relational database are using double OP concepts. What is double OP? Object මේවා දන්නේ නැහැ. Oriented programming concepts. This is something related to the programming concept. We have to do this in chapter 9. Double OP කරන්න තියෙනවා. ලොකුවට නෑ ටිකක් තියෙනවා. Then you will understand it. Until then, just learn that object relational databases are improved version of relational database model, combining the object oriented programming concepts together. Then it's easy for the application developers to make applications associated with the database. ඔච්චරයි කතාව. ඔය ටික දැනගන්න කතාව හොඳටම ඇති. background එකක් තේරෙනවා නම් yes. හරි, we light the next level object relational database model. There we light is an improved version of the relational database concepts. Is an improved version of the relational database concepts supporting the application development. Supporting the application development. Supporting the application development. Within bracket, software development. Application development, within bracket, software development. Next point. Object-oriented programming concepts. Next point. Object-oriented programming concepts are combined with the relational database concepts. under object relational database model, under the object relational database model, making the software development, more comfortable. Software development එක comfortable වෙනවා ඔන්න ඔය විදිහට. Then they are the models of databases. Flat, hierarchical, network, relational, object relational. කතාව හරි. Okay, පොඩි theory එකයි තියෙන්නේ. MCQ එකක් වගේ target කරන්න. Sometimes maybe there or may not be there. ඊළඟට යනවා the next concept. That's very important. Keys used in databases. Keys used in databases. Right. People who did ICT for O levels might have heard about primary keys, foreign keys, related to databases. Not only that, there are many other keys available: super key, candidate key, alternative key, primary key, key like that. You'll see what they are. You have to learn. Right? Then, simply key in our database concepts are referring to special fields of a table. What are fields? Rows the columns there. Columns. Among the columns, some special columns are told as key, highlighted columns. Then depending on the specialization, we are going to categorize them into multiple types of keys. That's the idea. Right? We like the topic keys used in databases. So we like keys used in databases. That we like. The columns available, the columns is not fields. The columns is not fields. Columns is not fields available in a table. Columns, fields available in a table are defined as keys. Based on specializations. Namely, we list them. Super key, part B, candidate key, part C, alternate key, part D, primary key, part E, composite key, then F, foreign key, likewise. We'll learn what those keys step by step. Right. First we go to the super key. This idea. I'll write the definition. You may understand this, right? It's English. Try to understand. Super key is defined as a column. A column or a combination of columns. What is that? English? Super key is a column, that means field, or a combination of columns, set of columns, which are used to identify records uniquely. What are records? Records are full row with data. Another angle. In the subject table, each record represents what information? This record is for MT11 math subject. This record is for MT10 math subject. This is for SC10, this is for IT10. Then each record resembles or represents what information? Each subject table records are displaying, records are giving you each subject. Likewise, when you go to the teacher table, each record gives what details? Teacher details. Right? This is one teacher, another teacher, another teacher, another teacher. Likewise, student table, I erased that already. Each record represents each student. Now, primary key means a column or a combination of columns. We'll go to the subject table, resembling subjects in each record. Right. Super key means a column or a set of columns which are used to identify records uniquely. Now, here the records are representing subjects. Now, it should be a column to identify subjects uniquely. You know that. What is that column? Which can be used to identify subjects in the subject table. Subjects identified by what? From the practicals column, can we identify the subjects? අපි එහෙම subjects වලට කතා කරන්නේ නැහැ. මම අහන්නේ මේ මචං අර subject එක practical නැති subject එක. එහෙම කියලා අපි subject හොයනවද? නැහැ. From the name, is it possible to identify the subjects? Maths subject. Then that's fine. But won't the subject name technically create duplicates? We have maths for grade 10, grade 11, many more things are there. And what is the uniquely identifying column for the subject table? Subject ID. So I will never have MT11 again. Right? Now, it is a column or combination of columns, set of columns to identify records uniquely. With respect to the subject table, what can be the super key? Column or set of columns to identify records unique. What is it? Sub ID. Sub ID will identify the subjects unique, no issue. This is going to be a super key. Is it possible for me to consider sub ID, comma, sub name as a super key? This one, sub ID. I'm asking, what is the subject? What is the subject name of SC10? What is the name of the subject SC10? Can you find it? SC10 is a column to identify subjects, right? Sub SC10 and science, no issue. I can use sub ID alone to identify records. Now I am going to use sub ID and sub name. Then how can I recognize the subjects? I'm telling that what is the whatever the detail, right? Do we have practicals of SC10, which is a science subject? Right? SC10 science. Do we have practicals or not? Can you answer that? Full one. SC10 and science, both the columns, won't it recognize the records uniquely? Why? Since this is unique. May unique if I combine more than one column, no matter, the set will still maintain the uniquely identification. Subject ID විතරක් අපිට consider කරන්න පුළුවන් records identify කරන්න. හොඳටම හොඳයි. ඒ විතරක් නෙවෙයි. Why? Our definition says that super key definition is a column or a combination of columns. මෙන්න මේකනේ විස බීජේ. column එකක් නෙවෙයි, set of columns උත් පුළුවන්ලු to identify records. එහෙම වුණත් අපි කියන්නේ මොකක් කියලාද ඒකට? super key කියලා. එහෙනම් initially I may consider this column still possible. ඒක විතරක් නෙවෙයිනේ. If I join this column with some other column, now both will still maintain the uniqueness and the couple can be used to identify the records uniquely. එමත් පුළුවන්. එහෙනම් into this table how many super keys are there? 1 or 2? Can't there be 3 even? 3 වෙන්න බැයිද? Sub ID and practicals. Can't those two be used to identify records? Sub ID එකයි practical එක අරගෙන මට records identify කරන්න බැයිද? ඒත් පුළුවන්. ඇයි බැරි? ඇයි මූ unique නේ? දැන් මම අහනවා what is the subject name of MT11 and practical having no? The subject name of sub ID MT11 and having no practicals. Won't there be any other record? No. එහෙම යන්න පුළුවන්. ඕක තවත් detail වෙන්න මම මෙතෙන් එන්නම්. In this table, now I am asking a super key for the teacher table. සංකල්පයෙන් දැන් ඒකට a super key. A single column to identify teachers uniquely. Teacher ID. Is that all? Can I consider teacher ID as well as teacher name to identify records uniquely? දෙකේම මට පුළුවන්. I'm telling that these both will be used to identify teachers. T1 and Manel. It will won't get duplicated. තවත් Manel කෙනෙක් හිටියොත් ඕන Manel නේ. Same ID can't be there. And then that would be getting somewhere like 58,000. Telephone number would be 077444. How many? Then if I consider both teacher ID and the teacher name, I'm asking what is the salary of T001 Manel? And can I refer to this? No. Yat Manel tamai හැබැයි T001 Manel both me nam consider කරන්න. No issue. And can I consider TID as well as the telephone to identify teachers uniquely? Then මං කියනවා what is the salary of the teacher T002 and the telephone number 077222. Is that practical to identify records? පුළුවන්. ඇයි මෙයා unique හන්දා මෙයාත් එක්ක මොකක් merge කරත් uniqueness and the identification is maintained. එහෙනම් දැන් මං යනවා තව එකක් TID, TName, salary. Can't all three be a super key? මේ තුනම ගන්න බැයිද? ඒත් පුළුවන්. එහෙනම් ඔක්කොම ටික ගන්න බැයිද? ඒකත් පුළුවන්. එහෙනම් into a table how many super keys can be declared? One or many? Many. හැබැයි if I consider salary and the T name, can this be a super key? Salary එකයි T name එකයි ගන්න පුළුවන්ද? T name එක duplicate වෙන්න පුළුවන්. එකම නම තියෙන එක්කනට එකම salary එක තියෙන්නත් පුළුවන්. මේ මානෙල් ටීචර් එකෙත් මෙයාත් මානෙල් මේ දෙන්නගම salary එක වෙන්න බැයිද? Possibility is there. If so, we can't identify them unique. ඒක හරියන්නේ නැහැ. But TID is added into that one, then that's fine. TID will not give you duplication. And that's the idea behind the way to detect the super keys. Right. Then we'll go to the first one. Getting late, right? Super key. We like super key. Okay, our example take ilang dawase අපි කරගෙන යන් for the moment, right? Super key. We like is defined as a column, comma field. Is defined as a column, comma field, or a combination of columns. Is defined as a column, comma field, or a combination of columns which are used to identify which are used to identify records, which are used to identify records uniquely, which are used to identify records uniquely. Example, the teacher table, example, the teacher table of the above school database. Teacher table of the above school database. හනේ ඒ කියන්නේ අපි ඉස්සලා example එක දාගත්තේ ඔය කියන්නේ ආයෙ කඳින්න ඕනේ නැහැ නේද එතකොට above school teacher table of the above school database we write after that comma next point teacher id is unique for each teacher. Teacher id is unique for each teacher. Teacher id is unique for each teacher and it is practical to detect teachers. Next point. Both teacher ID and T name. Both teacher ID and T name. Within brackets write TID, T name. අපි brackets දාලා තමයි සාමාන්‍ය ලියන්නේ ඔක. Both teacher ID and T name. මෙහෙම ඊළඟට ලියා ගන්න TID, T name. Still maintain a uniqueness to identify teachers. Also තව සෙට් එකක් ලියාගෙන යන්න එහෙනම්. තව සුපර් කීස් ටිකක් ලියමු. තව මොනවද? Also teacher ID, T name, cell. මේකත් සුපර් කී එකක්. හරි. තව ගත්තාම teacher ID, cell, tell. ඔහොම යන්නත් පුළුවන්. Or else teacher ID, E name, cell, tell, all. Still going to be a super key. ඕන තරමක් දා ගන්න පුළුවන් එතකොට. By mixing teacher ID and any other. හරි. After that we write. It is possible to maintain. Multiple super keys. It is possible to maintain multiple super keys for a table. Multiple super keys for a table. But T name, cell. But T name, cell. එක brackets එකකට දාගන්න. But T name, cell is not an SK super key. Is not a super key. මේක super key එකක් නෙවෙයි. එයි අපි දන්නවා ඒක uniqueness නැති හන්ද. හරිනේ. හරි ඔක තව example ටිකක් කරලා we'll go to the other keys, the candidate, alternate and many other things. So then they are technical. You have to learn that, right? ඔය ටික පොඩ්ඩක් update කරලා ඊළඟ දවසේ එනකොට especially the key part and the history or the development to continue. Right. Then I'll stop here. Hope to meet you on the coming week from the rest of the chapters.